Yeah, my name's Marcus. I'm a principal engineer at Fastly, and at the moment I'm focusing on our sort of observability stack. For those of you that aren't familiar with Fastly, and I wouldn't be surprised if you aren't, we power, we're a content distribution network and edge cloud, and we power sort of hundreds of the largest websites in the world. So you probably use us every day, but might not know exactly what the company is. So our network spans the globe. We have 51 points of presence, which are individual data centers scattered all around the world. Of those 51 data centers, we have 22 terabits of connected network transit to support all of that customer traffic and to get all of the content to you as quickly as possible. So as you can imagine, the importance of us being able to monitor the performance and reliability of our network is absolutely paramount. Both not only for our customers that are relying on us to deliver their content, but to all of you who want to browse Reddit when you're not working. So to set the stage, let's have a little bit of a chat about how we were monitoring Fastly. So Fastly is a relatively young company. We've been around for 7 years, and we've been monitoring since day one. So the original monitoring stack at Fastly was Ganglia. Who is familiar with Ganglia? A few people. Who still runs it as their primary monitoring? Okay, there's got to be one or two for sure. Okay, so Ganglia is an RRD-based monitoring solution. It was originally designed to support monitoring of high-performance computing clusters. So a lot of its functionality is centered around sort of this concept of clustering and having groups of machines that are mostly homogeneous. So for us, it was a pretty good fit because we have all of these data centers that are relatively the same. But it did have some limitations. So as we scaled as a company, so from starting 7 years ago, we started to have some growing pains with our Ganglia infrastructure. There's a pretty heavy operational overhead. So Ganglia is designed in sort of more traditional approach where you have a central aggregator and all of your infrastructure pushes its metrics to that central aggregator. So as our infrastructure was growing, we're just absolutely hammering this aggregator with more and more traffic. It's also quite a complicated system to run. There's a lot of components. It doesn't provide a lot of observability out of the box for how you can introspect how itself is running. So you're in a tangly mess of debugging XML and XDR over UDP, which is awesome fun, as you can imagine. Given that it's based on RRD, it has very limited graphing functions. So for the most part, most of the views will give you an average. And depending on how you set your sort of retention schema, you may sort of start to lose resolution over time, and that's always a trade-off between how long you want to keep the metrics around for and what your sort of functions are. And there's no native alerting support. So to actually bolt alerting into Ganglia, it required building a whole sort of menagerie of components that integrated with Icinga to be able to query Ganglia for metrics and thresholds and things like that. And you would end up with this real disconnect between the alert that fired and getting back to the actual graph that was measuring that thing that alerted. And there was no real API, and this sort of became more of an issue in later life when our data science team and our capacity planning teams were wanting to sort of take all of this juicy system telemetry that we have and use those for their research purposes or for capacity planning. So we're kind of a little bit stuck there. So moving along, a few years ago, there was an attempt at Fastly to try and get out of this mess. We'd identified these problems. What could we do to solve it? So we rub a bit of SaaS on it. Plenty of third-party SaaS vendors that do metric collection for you. So there was a project underway to kind of start to move a lot of the Ganglia stuff into Datadog. But it wasn't necessarily a move. It was more, let's do it in parallel. So the resulting situation there is now we've just doubled our pains. We're now supporting two systems. So we have metrics going to two separate systems. There's the perennial question around where do I put my metrics? Do I put them in Ganglia? Do I put them in Datadog? Do I put them in both? Where do people expect metrics to be? So the consumers of the systems would be expecting certain metrics to be in one of the systems that wouldn't be there. It was just confusion and horror. We were still having to write a lot of black box monitoring sort of plugins and agents. So both of these systems relied on sketchy shell scripts and Python code that would go and try and sort of infer the performance and the characteristics of the services they were monitoring and then emit those metrics out. And we really kind of would have preferred a sort of a more white boxy approach, and it was very limiting with both these systems. And monitoring was always treated as like a post-release phase. So folks would ship a new service, And then once it would be thrown over the wall to ops, it would be a case of, oh, now we have to add monitoring. And there'd be a mad scramble trying to figure out, A, what should I be monitoring? Because there was that disconnect between the sort of the engineers that wrote the code and the operators who were running it. And yeah, it was essentially the equivalent of like, we'll write the documentation later. So we'd have missing monitors or we wouldn't have the right monitors. And then the sort of underlying problem that we had was that as our infrastructure scaled horizontally, so we're adding more and more POPs and more servers, both of these metrics collection systems had to be scaled vertically. So in the Ganglia case, we need bigger NICs, we need a faster network, we need more disk I/O, we need more memory. Now we need a whole new machine and then migrate everything to the new machine. And this was like almost a monthly process at some point. And then on the SaaS side, we had to continue scaling the pile of money that we were giving them every month to be able to support this extended use. And both systems just sort of became untenable. So you might be thinking, okay, well, we've got 2 monitoring systems now. Should we throw a third in? So maybe we'll get lucky this time around. So we had a few goals in mind when we started thinking about if we were to redo our sort of monitoring at Fastly, what would we do? And what were sort of some of the high-level requirements that we would have? So the most important one really was that we needed a system that would scale with our infrastructure growth. So as we started rolling out more infrastructure, we really needed the monitoring system to not get in the way of that. We wanted a system that would be easy to deploy and operate. So we don't want to have to be burning ops cycles on trying to keep the system up. And the system not being up is sort of loses its critical visibility. We wanted a system that also was really friendly to engineers so that instrumenting your applications was not an onerous task. We have, in the Ganglia days, we did actually have a couple of applications, core applications, that had built in the geometric libraries themselves, which is, if you thought UDP and XDR and XML was bad, like those libraries were even more terrifying to integrate. So we wanted it to make it really easy for engineers to instrument their own applications. And we wanted first-class API support. It just makes sense if you're putting data into a system, you should be able to get it out in any way that you see fit. And the last thing that I'm just going to mention really briefly, so Peter Borgon was my sort of partner on this project. He and I are sort of still working on it and have been for the last sort of half a year. He did a presentation at Monitorama earlier this year, because the other aspect of it was we really wanted to try and transform the monitoring culture at Fastly to move it to be more of a everyone's involved kind of approach. So Peter's presentation is online there, and that goes much more into the detail of the sort of the work we've done to change the monitoring culture at Fastly that is sort of like the companion piece to this presentation. So now that we have identified, yes, let's try and do this project, now we have to decide what system are we going to use. So it had to be on-prem, so it limited the sort of solution space there for us. But most of the on-prem solutions that we looked at still suffered from a lot of the same problems. We had this central aggregation point. We had to be pushing all of our metrics to that single aggregation point. The newer systems did offer things like clustering and sharding, which would help the data volume scale and the sort of ingest capacity scale. But again, that sort of felt to be quite a significant operational burden to take on. So what else was there out there that we could possibly use? And no surprises, Prometheus. So Peter had worked at SoundCloud previously with Julius, and was one of the very early, was using some of the very early versions of Prometheus, I think before any of us got to see it. And he said to us that he was amazed at like this sort of more revolutionary approach to monitoring. So we figured, well, let's give it a go. I did some initial testing and just getting up and running in a few minutes was really simple and awesome. So we figured, let's go with that and see how we go. So what do we need to do to get started? First thing was to build our proof of concept infrastructure. Building the proof of concept, we took a tracer bullet sort of design methodology, and that sort of tracer bullet design is where you sort of pick how you want to build your architecture and build it with all of the rigor that you would with a production system. So given that we sort of had this large geographical set of POPs, it was let's build it in a couple of POPs, but with full production capacity, so we don't have this sort of horrible productionization at the end stage, should we decide to go ahead with things. As part of the sort of cultural thing, we really wanted engineers to sort of be fully empowered to have all the skills necessary to instrument their own applications, write their own dashboard, build their own dashboards, write their own alerts. So part of this project was to pair with these teams and bring them in gently to the Prometheus world. So we would pair with a pilot team, who were one of our early adopters, to instrument the services that they ran, help them build their initial dashboards and alerts, and use them as leverage for the other teams to kind of build the excitement and advocacy for Prometheus. We then continue through the rest of the teams, same kind of process, run both systems in parallel, make sure that they're all doing the same thing, and then we decommission the SaaS system in Ganglia. And we're kind of in the middle of decommissioning the SaaS stuff now. Ganglia will probably stick around for a little bit longer. So now onto the sort of technical side of things. What does Fastly's infrastructure look like for Prometheus? This diagram's probably unsurprising to everyone in the room. I think everyone's kind of alighted towards this as the way that you run Prometheus in a high availability way. So in each of our individual POPs, we run a pair of Prometheus instances. It's fantastic that they have local storage and they're shared nothing. Both of those instances scrape all of the devices that live in those POPs. So we have all of our servers and network switches and PDUs. Both of them scrape all the metrics. That's awesome. And so that's like our San Jose POP. We then take that pattern and stamp it out across our whole infrastructure. So every POP gets exactly the same topology. And so for us, in terms of doing this traceable at design, once we'd sort of built out the chef code and everything to build out our Prometheus instances in one POP, it was trivial to roll out to everywhere else. The other component in our stack is what we call our front end. So our front end runs on Google Cloud Platform, and it consists of a few components. We have Nginx operating as our sort of reverse proxy router. Nginx allows users to just pass a URL path, which will route them to any of the Prometheuses in our global infrastructure. We have Grafana, obviously, for all of our alerting and dashboarding, and a very long list of sites as data sources. And we have a couple of federators and also Alert Manager cluster, but I'm not going to talk about those. I think everyone's kind of familiar. Now, one of the real important aspects of Fastly's infrastructure is, unlike a lot of folks, we don't really have a private corporate network. Like, we don't have a back-end network. Our back-end network is the internet. So for requests to go from the front end to all of our Prometheus instances, it goes across the internet. So what we needed to implement there was we needed full TLS. Not only TLS, but TLS and authentication from the front-end instances, from Grafana and the federators and everything. Needed to be able to reach every Prometheus around the world secured with TLS. So let's talk about what our service stack looks like on an individual Prometheus server. So the first component we have, which is what gave us the TLS magic, was a package called Ghost Tunnel, which is released by Square, open source, and it's an awesome lightweight TLS reverse proxy that also does mutual authentication. We're using that for almost everything now, everywhere, not just for Prometheus. Highly recommend. We have a service discovery system that we've built. One component of that is the sidecar, and I'm going to go into more detail about this shortly, but it's responsible for sort of preparing the entire Prometheus configuration. We have our rules loader sort of daemon process. At Fastly, we use a sort of GitOps approach to managing all of our alerting and recording rules. So any engineer in Fastly is sort of empowered to go and write their own recording rules, their own alerting rules. Open a PR, have it reviewed, it runs through our linting and validation, and then when it's merged to master, that process is responsible for updating those recording rules on every instance around the world, and it's nothing more clever than like git pull in a cron. And then, of course, Prometheus. Then on the server side, so a typically instrumented server at Fastly, it's radically simple. We have our exporters, obviously. They're either built into the services themselves or they operate as a sidecar for those horrible things like Ruby apps and whatnot. And then we have the other component of our service discovery system, which is the service discovery proxy. And we're going to sort of talk about those now. So why would you want to build your own service discovery? So Prometheus out of the box supports somewhere, I think, between like either 12 or 14 different service discovery mechanisms. But unfortunately for us, as well as having the internet as our corporate network, all of our Fastly infrastructure is bare metal. It's old school, racks and stacks in data centers, and it's all bare metal. So we don't have any of the conveniences that you get in like a cloud native architecture. So you don't have beautiful APIs for doing everything. We do have some of our own internal systems, but obviously they're internal and bespoke, so they don't sort of have a out of the box solution. And what we ultimately wanted was we need the ability for our Prometheus infrastructure as it grows to just configure itself for the most part. And we didn't want to use Chef because reasons. So what requirements do we have for building this like service discovery mechanism? We wanted automatic discovery of targets. So as we would roll out new machines or roll out new POPs or roll out new services, we wanted them to just magically be automatically instrumented without anyone having to do a lot of work. We wanted self-service registration of exporter endpoints. So while we're trying to empower all of our engineers to instrument their own applications, they'll be exposing Prometheus metrics either on a special port or under a special path in their application. So we wanted them to be able to register where their exporter will be exposing the metrics to our configuration system that we could consume later on. We obviously needed TLS encryption for all exporter traffic. It's sort of like a non-negotiable at Fastly. And we want a minimal exposure of TCP ports for exporters. So on a typical system, we have anywhere from 15 to 25 different exporters running. We didn't want to have to be exposing TCP ports for every one of those. So that kind of set the stage for what we needed to plumb this whole menagerie together. So at a very high level, going back to the original sort of diagram, these are the sort of interactions of the two components. The sidecar queries the proxy to say, hey server, what targets do you have available for me to scrape? The sidecar also generates the configurations that Prometheus uses. And Prometheus then calls the proxied endpoints via the proxy, so what we're exposing externally. And then that takes care of it getting routed to the actual exporter running on the machine. So let's go another level deeper. What does the sidecar do? So the sidecar process runs on our Prometheus server, tiny little Go daemon. First thing it does is our sort of global configuration system's called Configly, because everything at Fastly ends with an ly. It's part of the onboarding requirement. So Configly is the runtime configuration for every service that we run and every machine that we run. So what PromiseD, the sidecar, and sorry, PromiseD is the internal name of this service discovery system, very imaginative. It queries Configly and says, okay, I'm SJC, tell me the IP addresses of every device in SJC. Once it has that, it then iterates over those and it asks the proxy that's running on each machine, which is the other component of this, tell me all the targets that you know about. So we sort of have these two data sources now of here are all the IP addresses. For each IP address, we have the list of all of the targets that are available on that system. From there, it generates a standard Prometheus file service discovery JSON file with the sort of compiled configuration. So in this case, here are the targets, here are the routes to the various exporters that traverse via the proxy, and then from there, Prometheus reads that file, and that's our target configuration. This whole process kind of runs polling every 30 seconds. And then when that JSON file gets updated, Prometheus just updates with the new configuration. So if we were to go and roll out a new host in this environment, it'll have a new IP address, it'll get picked up, and magically it's there without any sort of operator intervention aside from our standard sort of build and deploy process that adds that system into Configly. So now that we've talked about the proxy, let's see how the proxy works. So this is the other component. The PromiseD proxy runs on every one of our servers. So what it does first is we're sort of using systemd for everything. You've just got to embrace the overlords and be done with it. So we make dbus queries to systemd, and we ask systemd, tell me every service that you have running on the machine. From that, we then do a call to Configly to say, what's the runtime configuration for every single one of those services that you have? What we did in our configuration sort of schema is we added an additional map called Prometheus Properties. And in Prometheus Properties, you can specify the target. So that's the local address on the machine for where the exporter is running. So if you use Node Exporter as an example here, it's listening on localhost 9100. So that tells the system that's where to expect to find it. That could also be a Unix domain socket, which is something we're starting to look at and doing things like abstract kernel namespaces to even hide the socket if you want. And as part of the Prometheus properties, you can also specify additional labels. You might want to override the local metrics path and things like that. So you've sort of got a lot of flexibility in how you do that. But that sort of describes the relationship between the systemd process and how it's configured. And so from that, if a user deploys or an engineer deploys a new service, it pops up in systemd. If it's got a Prometheus properties, the PromSD, the proxy knows about it. And then that exposes the API that's consumed by both the sidecar and also by Prometheus. And from that API, the targets endpoint that sidecar requests will give the list of all of the targets that are available on that host. And then from that, Prometheus will use what we do is we have these computed paths. So for instance, /node exporter _ 9100 / metrics is the proxy side that routes to the local exporter running on the machine. It's a little bit confusing, but it's slightly simpler in practice. But it's working pretty well. So now that we have those two pieces in place, did it actually achieve what we hoped? So yes, it's really easy to leverage the file service discovery mechanism to whatever function that you need. There was a blog post recently about using it to do some Docker Swarm stuff. As long as you can generate the file in the right format, it just works. So that was really easy and really fun. New targets for engineers, all they need to do when they deploy their service is add that single Prometheus properties line. So if I spin up a new service and it's listening for metrics on 1, 2, 3, 4, we just add that line and it will roll out magically to the fleet. We have TLS and authentication everywhere, so every connection from every system that Prometheus touches, either Prometheus to an exporter or a query to Prometheus, is mutually authenticated and over TLS. And we have a single exporter port per host, which is a bit of a catch-22 in some cases, because now if PromSD proxy goes down, so do all your targets, which unfortunately a few dbus errors, because hello systemd, they will occasionally hang. But it's a really great proxy for the machine is down. Cool. So now we've done that whirlwind tour of getting things out. So what does Prometheus adoption look like at Fastly so far? So we started this project in November 2017 and sort of been working our way through. We've got probably about 70% of our infrastructure fully Prometheusized. So what are sort of some of the stats? So we have 114 servers globally. That's growing. There's many more to come. We have around about 28.4 million time series. We're still instrumenting a bunch of applications at this time as well. We're doing about 2.2 million samples per second. On the developer side, there was a little bit of hesitation. So one of our data science folks did a lot of work with our SaaS product to pull metrics out. And I just introduced him to Prometheus and given him his API keys, and he was ready to go. And he sent me this Slack, and he said, I'm still looking at the functions available in Prometheus, and it seems even more constrained than Vendor. He'd been burnt by every system at this point. And then I said, here's the awesome documentation. Go and have a look. If you're still having problems, let me know. And a few hours later, he sends me a tweet. It's much better than Vendor. And so much faster. And he's been loving it. He's one of our sort of biggest adopters. I think he wrote something like 800 recording rules the other day in one go. So PR, yeah, it looks fine, no problem. What were we saying? Well, what was getting mentioned yesterday about subqueries? Yeah, that would be really helpful. So overall, engineers love it. Everyone that we've worked with has just loved instrumenting their applications. They've found it super simple. And we've covered all the languages. We even have Perl applications that are pushing metrics into Prometheus as well. Dashboard and alert quality's increased, and that was sort of one of the goals of our cultural transformation, is to not be accepting of just alert noise, and to spend the time, because we were moving to this new system that required re-instrumenting applications and rebuilding dashboards and alerts, to really think like, what are the most meaningful metrics I need for my application? So they've increased tenfold. PromQL has enabled us to get some really deep insights, like the expressiveness of the language has let us do some pretty crazy things. I didn't sleep much last week with the Linux TCP kernel vulnerability that got revealed. And as we were testing the exploits and testing our mitigations, we were able to build dashboards and alerts as we were going to validate what we were seeing, to the point that within less than half a day, we had alerting for our whole infrastructure, had tested the exploit against our infrastructure to know that those alerts would fire if someone did come at us. And then as the mitigations rolled across the fleet, we could see the improvements and the progression of kernel roles and sysctl changes and some custom modules that we'd written. And ultimately, it had scaled linearly with our infrastructure growth. So having those building blocks of those 2 Prometheus instances in every POP. They're really simple to roll out. As we roll out more POPs and more infrastructure, it just grows with us. So we're not running into the situation of having this single aggregation point that's just getting slammed as we add more and more infrastructure. And the nice part about it is our POPs are actually relatively small. So we're getting nowhere near 5 million metrics per second on a single machine. So we have headroom for days. So our machines don't need to be that big for running Prometheus. But there are still some rough edges. And the first one is one that I kind of, I guess, proposed to the community, it'd be good to discuss at some point, is if you want to do ad hoc metric exploration. So we've kind of termed it breadth-first search for issues. So in Ganglia, what we would have quite commonly is something's gone wrong with a machine. It's not immediately clear what it is. I can tell Ganglia to render all 2,000 graphs on one page for me, and then use some mouse scroll wheel debugging ability to look for which things lined up at the same time. And that's actually really easy, and that's one of the workflows that happens a lot at Fastly, because we have a lot of sort of complexity and crazy stuff going on. So if you've ever tried to plot 2,000 graphs in Grafana with like 100 meg of JSON, if you want to crash Chrome real quick, that's a great thing. So if you don't have that sort of a priori knowledge of what you want, it would be really great to talk to anyone if they've sort of had this same problem or have any ideas of how you can sort of say, just show me all these metrics at once and let's kind of figure it out. We've got a sort of a rough prototype of just a rendering tool that does client-side rendering, sort of bringing the 90s back, which is kind of cool. Like if there was server-side rendering for Grafana, that would be sort of cool. Yeah, so that's a bit of an interesting one. Alert manager's flexibility. I don't know if it's possible for a system to be too flexible, but when we have hundreds of engineers and dozens of teams all writing alerts, the routing trees get terrifying, and your ability to completely screw over another team becomes really, really a reality. So that's a little bit of a challenge, and we've sort of abstracted a little bit around that to try and avoid things, which sadly has meant we've had to kind of like chop some features off from people because we can't risk the impact that their changes might have. And secondarily to that, the Alert Manager default search interface is fantastic, but a lot of users just want to see something sort of similar to Naglite, which is just show me a list of red and green of all the things that are firing or not firing, and maybe some filters to be able to do that. So I think with a sort of a V1 API for Alert Manager, we could maybe fix a lot of that stuff. Federation global views, huge topic. Typically, federation comes up when someone at Fastly will come and say, hey, I can't find this metric on the global instance. And it's like, yeah, it's not federated. And usually when they ask that question, they wanted to see it federated an hour ago. So the opt-in nature of it kind of gets a little bit tricky. And having that global view, it's sort of like a bit of a trade-off. Like when we're querying hundreds of Prometheus instances and want to have that aggregated view, you sort of got to do a bit of pre-thought up front, which is in itself not that bad. But yeah, for some users, it's a bit of a struggle. And long-term storage is a bit of an open question. So when we started the project, we knew this was the case. And we made a sort of a service level agreement with the company that said, we're going to keep somewhere between 60 and 90 days online. And after that, you know, it's all about real-time operational telemetry, not long-term trending. But now people have got a taste. They go, ooh, I'd love to see this in a year view or whatever. So we're currently evaluating Thanos and super excited about that. Thank you for building it. So ultimately, Fastly loves Prometheus. Prometheus also loves Fastly. And the whole project has been like a raging success so far. I couldn't have asked for anything better. So huge thanks to the whole Prometheus community and the developers and everyone and the Grafana team that have really given us something that's let us solve some of these problems that we've just had to like struggle through for the last 10 or 15 years. So thanks.
Thank you, Marcus. We have a couple of minutes left for questions.
Hi.
Hi.
Question, where do you add labels to your things?
Where do we add labels? So from which dimension? So if you're instrumenting your application, you can add the labels there. We don't do any label addition specifically.
Okay, because you add the targets, and then how you know where the target is, in which...
All those labels pass through. So as far as the exporter is concerned, it's just being called locally. we sort of do a bit of mutation with the metrics paths and things to be able to get around that. So for the most part, it feels very much like you're just talking to a native system and you don't know that that sort of sidecar and proxy layer exists at all.
Hey, you mentioned that with a lot of people using Alert Manager's configurations, it's possible to mess things up for other people without realizing it or anticipating it. Can you give a slightly more concrete example? I'm just kind of curious what kind of things might come up.
Yeah, so it's kind of like that fall-through behavior. So at the moment we have a sort of a structure where teams are kind of allocated a special name, and that maps to their Slack channels and it maps to their pager duties. And what we've had is we've had engineers who have said, well, I want this alert to go to more than one destination. So if you're listing a Slack channel, if you want to go to multiple Slack channels, it needs to be multiple sort of routes for it to get there. So at the moment we have like a single set of global routes, and once it matches one, it bails out. But if you want to fall through, there's the potential that you may have other alerts. That's one of the immediate ones that we've run into. But even trying to kind of understand and grok how it all hangs together is, takes a little bit of work.
Hey,
anyone else
over here?
Yes.
As a happy Fastly customer,
Yes.
Is there a plan to export metrics for customers?
Would love to. One of our core Varnish engineers, which is like the sort of the underlying technology that we have, he's one of our number one customers. So we're looking at building for ourselves, building in native Prometheus exposition. But yeah, it would be pretty awesome to. We're definitely thinking about it. No promises.
Had you had to look at the exporter, because it solves, I think, large part of your problems as well. It also proxy with HTTPS and so on. I don't know if you know it.
Yeah, totally. Yeah, totally. There's a bunch of exporter type projects that do allow you to do the TLS and things. But the key for us was we needed to be able to tie into our configuration system. And so like the actual service discovery PromSD stuff we wrote, it's like 150 lines ago. It's not particularly complicated, but we are having to make a few adaptations specifically to our environment.
Yep. Hello.
Yep.
Thanks for the talk.
Nice.
My question is, I could see the two Prometheus servers in a HA. How you handle the duplicated stuff?
That was the slide I took out. So what we do with the A and B is that we have Nginx configured with Nginx upstream with two hosts, and it's just failover. So if A disappears, it'll fail over to B. Because what we didn't want to do with the load balancing is, because you have that sort of the scrape intervals can get slightly out of whack. You don't want those graphs to like oscillate if you're getting slightly out of time metrics. So yeah, we bias the A. We've got plenty of CPU and disk and headroom to do that. And then should it fail, Nginx fails over to the B.
Hey, how's it going?
Hi.
Comment and question. So first of all, great talk. Really enjoyed it. So
Thank
the comment is, just wanted to thank you guys for powering all the downloads for the Grafana open source project. Really
awesome.
Appreciate it. And the question is, you mentioned after going through sort of your on-prem, sort of monitoring solution 1, on-prem, monitoring solution 2, SaaS, that it was sort of a foregone conclusion that you wanted to go back to on-prem. Just curious, was that a philosophical decision, or was it more driven by just the irrationality of the SaaS pricing?
Oh, the long question or the long answer or the short answer? All of the above. So there were, once you've used PromQL, it's really hard to use any other SaaS product. Like that's a bit of a starter. At our scale and the amount of custom metrics and things that we export, the price does become like a realistic factor. And the other factor was, and we sort of ran into this a few times, is that there's the whoownsyouravailability.com. And if you are relying on a third party as your eyes into your infrastructure, and you're powering the infrastructure that SaaS vendor might possibly use, you end up in a situation where they go down, you can't see it, you don't know it, you can't bring them back up. So you kind of end up in this crazy loop. So it's a little bit of all, and the SaaS products are amazing at what they're able to do now. But for us, it was just a better fit to bring it back in-house. And it's so cheap to run now, like given how lightweight Prometheus is.
Thank you, Marcus.
Thank you. Thanks, everyone.